today lecture, which is chapter 5.
On the test, number 8 was I don't think it was solvable because it didn't have like numbers or values to solve for.
Numbers. Did I give you 1200 at the beginning of the problem? No?
No, you didn't, because I
Okay.
rewrote it down and
Yeah, I missed that number. Somehow copy paste. I'm kind of lost that number. No worries. If the problem is wrong, if there is no number, I'll give you points for that problem, correct? If it's my problem, you are not responsible for. You will get your grade.
okay.
Yeah, don't worry. Okay, let me share the screen with you. Let's start chapter 5, interesting chapter. You will see a lot of new concepts here that you never saw before. Let's slowly start chapter 5. Chapter 5 is integrals. Your 5.1 is areas and distances. Look, in chapter, even the other day I explained a little bit. I don't want to again say all those words to you. The second part of the calculus or the second branch of calculus is finding the areas under the curve. The first one was finding the rate of change, which was the slope of the tangent line. The second part is finding the areas under the curve. If I have a rectangle like this, if I ask you to find the area of this rectangle, it's really easy for you, even you learned it in school, that how to find the area of a rectangle. Of course, length times width, L times W, is the area of this rectangle. Or if I give you a triangle like this, again, it's really easy for you to find the area of this triangle, correct? Which is A equals 1/2 of BH, right? Base times height, 1/2 of base times height gives you the area. Even if I give you a shape, for example, like this, maybe, which is not a good shape, still you can find the area of this shape without calculus, because what will you do? You divide this shape to 3 separate triangles and you name this area A1, you name this area, for example, A2, you name this area A3, and then you will say, okay, A is equal A1 plus A2 plus A3. It's easy to find these areas. That means the areas that you are only dealing with straight lines, correct? It was easy, it's easy to find those areas. Even you used a formula to find the area of a circle. That formula was ready for you, correct? That formula was ready for you. You just plug in the radius times pi and you can find the area of the circle easy. But now you are in calculus. I will not give you a triangle. I will not give you for example, rectangle, correct? Or a straight shape. Maybe I'll give you a function, not me. You're dealing with a function anymore right now. Maybe the function is like this. Now, if I ask you to find the area under this curve and x-axis, it means this area. If I ask you to find this area, let's name it S. It's not easy to find in a closed interval AB, right? It means I have a continuous function y equal f of x, whatever that curve is. F of x is a function. If I ask you to find the area under this curve, it's not that easy like what you learned in algebra, correct? This is the topic of discussion of integrals. Slowly, by using integrals, you can find the area of under any curve that's continuous in a closed interval, or even between two curves, bounded by two curves. Here, my curve and x-axis, sometimes you find the area between two curves, correct? An area that's bounded by two curves. For example, you are designing a road like this. Someone is asking you, your boss, okay, find this area for me, bounded by these two curves. Calculus gives you the power to can do this, to can calculate. Or you are designing a house, one side of the house is like this shape. To make it beautiful, you design one wall or one side of the house like a curve. Someone is asking you, okay, how much is this area of this room, which is this side is a straight, this side is a straight, this side is a straight. How much will be the area of this room? Calculus gives you the power to can calculate that. Now, the first method that I will teach you today is the rectangle method, correct? We call it the rectangle method. Rectangle method is really a method that even during the ancient time, mathematicians were using the rectangle method to find the areas under the curve, right? If I draw that curve again here for you, I draw a curve here for you. For example, this is X, this is Y. For example, I have a curve like this. In a closed interval AB, correct? Closed interval, it means you take a part of your function and you know this value of A and you know this value of B. And this is a function y equal f of x, any function, I don't know which function. This curve is a function for me. You can find the area under this curve. Even I cannot say you can find, you can estimate the area under this curve by using the rectangle method. How? What we do at the beginning, we divide the area under the curve to equal rectangles. Equal means this side is equal, y equal, because it makes it easy for us to calculate. You can divide to different width, but it gets a lot of time to calculate. Why we divide to equal rectangles? Because it's easy to calculate, correct? First, we divide the area under the curve to equal rectangles. Mine is not equal, definitely. My hand is shaking, correct? It means this portion and this portion is equal. All of them, they are equal. Now, there are three ways to calculate the area under this curve. First, you can connect the left side or the left end of your rectangle to the right side and create a rectangle like this. That's the first method. We call it the left end calculation, correct? All the left ends. Look how I'm taking the left side of this rectangle. I'll bring it here. I'll move this one a little bit up. This one will be the second rectangle that I will calculate. And I know already the formula for rectangle. It's easy to calculate the area, right? This one will go this way. And I calculate it easily how much. This side go like this. And I will calculate, and this side goes here, I can calculate, and this side goes here, I can calculate, correct? We call this method the left end, or you can call it the lower sum. Later, I will show you why we call it lower sum. We call this one the lower sum, or left end. Same way, I can connect the right side to the left side, and I can calculate the rectangles, the area of these rectangles. But in general, at the end, when I'm adding all these areas, these two sums are close to each other, but they are not equal, because you see this missing part? I'm here missing this part. I'm not calculating this area. Here I calculate more than even above the curve, which is not under the curve. Here above the curve, here above the curve, here I'm missing, here I'm missing, correct? It's kind of estimation. Let me show you the right hand also. Then after that, I'll explain what's going on if we increase the number of those rectangles, correct? Same curve, for example. I did the left hand for you. Now, how to connect and calculate the right hand? Again, divide the area under the curve to equal rectangles. On the right side, what you do, on the right side, you connect every end point of the right. You're coming this way to the left. Here it goes like this. Here it goes like this. Here it goes like this. Here it goes like all the way to here. We call this one upper sum, correct? This is the lower sum and upper sum method. What you do, any function that they give it to you, I'll show it an example for you. You calculate the upper sum, you calculate the lower sum. Of course, you will end up with two different numbers. The number which is between these two, we call it the estimation for the area under the curve. Remember your limits that you are moving point C, point D to point B to, or Q to P, you're moving, bring it close, 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 close. Actually, I'm using that method here, not in limit. I'm using that method to find these areas, correct? The other way, there is also even, they created another way. They said, okay, instead of going to find the upper sum and lower sum of the curve, I can use sample point or midpoint method. Again, this is the same curve. I cannot draw all of them the same because I'm using my hand. Of course, my shapes are different. You can use the midpoint method to calculate the area under the curve. What you do, these small intervals, if I name from here to here, for example, x1, x2, x3, xi, xn, xn minus 1, you divide this interval, this small distance, in half. We call this method here in half, here in half, here in half, and you connect the halves with each other. We call this method the half or the midpoint method for calculating the area under the curve. I will show you in different examples. I know here I explain a lot, maybe it's not clear for you. Let's start with a very simple example, a curve that you may already know that curve. Let's say, let's find the area of the curve y equal x squared in a closed interval 0 to 1. I want to calculate this area. Everyone knows the shape of y equal x squared? No problem, right? I choose the easy function. Y equal x squared, a parabola opening upward. All of us, we know this shape, right? Let me draw that. I'll kind of use a bigger scale here. That will be my 1, and here 1. If I plug in 1, Everyone knows the shape of the parabola that passes y equal x squared from 1, 1, right? It's a curve like this. I zoom it a lot, correct? I zoom it a lot. You know, your y equals x squared is a parabola like this, and it's passing from 1, 1, correct? I didn't draw the other side because I'm just calculating the area under this curve from 0 to 1. Here is your 0, here is a 1. It means they are asking me to find this area from 0 to 1 under the curve, correct? By using maybe 4 rectangles, they will give you how many rectangles to use, correct? By using 4 rectangles, I will divide under this or this distance to 4 equal pieces. That's my first job to do, correct? Let's divide. Here, half. Here, 1/4. And here, 3/4. Agree? 4 equal pieces. Let's draw our rectangles. Here. First, let's start with the upper sum. Upper sum means let's connect the right end to the left end, correct? See how I'm connecting the right end to the left end. The right end to the left end. The right end to the left end. And the right end to the left end. Why I did this? Because I want to calculate this area, the area of this rectangle plus the area of this rectangle plus the area of this rectangle plus the area of this rectangle. Question up to this step, how I did. They said use 4 rectangles. I divide the distance from 0 to 1 to 4 equal pieces. And first I want to use the upper sum. That's why I connect the right hand or the right end to the left end. And I want to calculate these areas. Okay, let's calculate. Let's name the right upper sum. Usually in your book, they call it Rn. From the right, you are calculating the area from the right. N is the number of these rectangles. How many of them I have? 4, right? Let's calculate the area of R4. If I name this one R1, if I name this one R2, if I name this one R3, this one R4, then R4 equals R1 plus R2 plus R3 or R4, correct? If I name it in general, Rn equals R1 plus R2 plus R3 plus R4. Question for you. Rn or R of 4, the sum of these 4 rectangles from the right. How much is this small rectangle? How much is the width of this rectangle? How much is the length of this rectangle? How much is this from here to here? Any idea?
1/4.
1/4, right? And the formula for rectangle, you know, L times W, right? Length times width. How much is this side? Give me an idea. How much is this point? How much is this length? Any calculus student in the class? How much is this height?
Oh, would it just be 1/4 times 1/4?
How? Why? Excellent. Good job.
Oh, why?
Give me the reason, because this is your f of x, right?
Yeah.
And you have to plug in 1/4 in your formula to get this height, right? You have y equal x squared. It means your height is 1/4 square. Agree? Plus second rectangle. Again, how much is this distance? From 1/4 to 1/2? Again, the width is the same, 1/4. Times, if I ask you to find this height, you have to square 1/2, right? Times 1/2 square. Plus, again, this distance is 1/4. Times the height, it means 3/4 square. Plus the last one. Again, this distance is 1/4. Times the height, it means 1 square. Any question on this step from where I found 1/4 and why the other side is a square? Because remember, to find these points, you have to plug in the value of x in your function. This gives you the value of y or f of x, right? Which is the other side of your triangle. Any question? Now let's calculate. It's really easy to calculate. You see here I have 1/4, here I have 1/4, here I have 1/4, here I have 1/4. I can make my job easier. Then I can say R4 equals 1/4 times, simplify the rest. 1/4 square gives you 1/16 plus 1/2 square gives you 1/4 plus 3/4 square gives you 9/16 plus 1 square gives you 1. Let's add this 4 number. Then R4 equals 1/4 times, you need a common denominator, right? Here times 4 times 4, here times 16 times 16. 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 16 is 30 over 16. Let's simplify. R4 equals 2 times 15 times 15 over 32. Which if you divide using your calculator, you will end up with 0.4685, a number like this. Correct? What is R4? R4 is all these shaded areas. I want to find the area under the curve. Now, question for you. Is this number is greater than the area under the curve, or is smaller or equal? What do you think?
Greater.
Greater, yeah. You see these extra areas here? This one is an extra area for me. This one is an extra area. This one is an extra area. This one is an extra area. That they are not under the curve, they are above the curve. That means the area that I found is actually the area of the curve should be less than this number, which is 0.46875. Correct? Now what I do, I will find the area of the curve connecting the end points from the left, which we show it usually with L. I will graph the same graph here for you. For example, here 1, here 1. This is the curve, y equal x squared, correct? And again, here 1/2, I will divide by 4 equal pieces to 4 equal pieces. Here 1/4, here 3/4. Correct? Let's draw our lines. Let's divide the area. This time, what I will do, I will connect the left endpoint to the right, correct? If I connect here, it doesn't give me even a rectangle. I will connect this point to here. I will connect this point, the left to the right, the left to the right. It means now I'm calculating this area, these rectangles. Let's show this one with Ln or L of 4 because you are coming from the left. Correct? The calculation is the same. The method is the same. L of 4 equals, again, this side of the rectangle is equal to, for all of them, which is 1/4. Times, how much is this side, this height? You're plugging now the left, correct? You see, even you don't have a height for the first one. It's
0.
0 plus, again, 1/4 times, now, how much is this height from here to here? 1/2 square. Plus 1/4 times, how much is this height? 3/4 square. And plus 1/4 times. Next one, the first one 0, the second one 1/4. This one is 1/2, and this one is 3/4. Again, you see 1/4 is common in all of them. You can make your calculation easy. 1/4 times 0 square is 0. 1/4 square gives you 1/16. 1/2 square gives you 1/4, and 3/4 square gives you 9/16. I didn't put here 0, even you can put 0 plus if you wish, but it's 0, right? Common denominator here times 4 times 4. 1 plus 4 is 5. 5 plus 9 is 14/16. It means L4 equals 1/4 times 14/16. 2 times 7 times, it means 7/32. And if you divide, I think this one becomes 0.21875. Now, question, is this number A is equal to the area under the rectangle, less than the area of the under the rectangle, under the curve, or greater? What do you think?
Less than.
Less than. It means your A is greater than 0.21875. Now, at the end, we guess like this. We estimate like this. We found two numbers. Okay, the area under the curve is definitely less than 0.46875, which was my upper area, correct? Or upper sum. And it's definitely greater than 0.21875, which is the lower sum. What do you think of a number between 0.2 and 0.4? What is that number? Can I say my area is approximately is kind of 0.3? Because between 0.2 and 0.4, the only number that fits is 0.3, correct? This is how you estimate the area of a curve under a curve and bounded by x-axis using the triangle method, correct? You're just using the formula for the area of rectangles and you add all of them. Question? Yes, no?
Wait, so to get 0.3, did you just like eyeball it and say like, oh, it's in between, or?
Yeah, the area is in between because your A should be greater than the lower sum, but less than the upper sum. You see these, all these graphs that I draw for you? Your A, the actual area under the curve, which is this area, right? If I shade it in a different color for you, maybe this dark blue, actually you are looking for this area under the curve. The goal is to find this area under the curve, right? You see it's less than the upper sum, but this area is greater definitely than the lower sum.
Yeah.
That's why we choose a number between the upper sum and lower sum. But it's just for this section. Next day, you will do this. Okay, I have y equal x squared. To find the area, area means integral. Okay, from where to where? They mentioned from 0 to 1. What is my function, x squared? You already learned what is the antiderivative of x squared? The other day we practiced. What is the antiderivative of x squared?
X squared over 3.
X cubed over 3. Very good. Okay, x cubed over 3. You plug in the upper sum, which gives you 1/3, minus the lower bound, which is 0 over 3. It means 1/3 minus 0. It means 1/3. What is 1/3? 0.3. You don't need to go this long. Using integrals, you can find easily the area under a curve, and x-axis or between two curves, but I have to explain for you what is definite integral, what is bounds. I will explain all those, then you go easy way. For time being, the rectangle method. Like you remember limits? You are approaching from the left, plug in different numbers. Approaching from the right, plug in a lot of numbers. And at the end, you would tell me at the beginning of the semester, okay, my limit is this much. The same way we start with these integrals, correct? Let's do another example to make it more clear. Before going to that example, let me explain something else now a little bit, because you got an idea. What is this idea, correct? Let me give you a definition now. The area of A a region S that lies under the graph of F, or let's say the graph of continuous function, any continuous function, now name it F, continuous function F, is the limit of the sum of the areas of approximate rectangles. What does it mean? I'll explain it to you. Why limit? Why limit gets involved? Let's say this curve. This curve, first of all, is this a continuous curve? Do you see any hole break in it? No, this curve f is continuous, right? Y equal f of x. That's why I use their continuous function. It's continuous. The area under this curve is the limit of the approximate rectangles. For example, you can divide the area under the curve to 1, 2, 3, 4, 5 rectangles, correct? You can estimate the area. Or I can divide the area under the curve to 8 or to 16 rectangles. What do you think? If I increase the number of rectangles, my approximation will be really, really close to real number. Agree? Yes or no? If you increase the number of these rectangles, you will get a better area. You see even here, because the missing parts will come lower and lower and lower and lower because you increase the number of rectangles. Even I can make more rectangles, more rectangles. It means if I show the number of rectangles by n, your n can approach to where? You are increasing n. Your n is approaching to where? To infinity. As much as you have more rectangles, you will end up with a really good approximation, which is close to reality, correct? That's why they give you this definition. And if you now, after this, you calculate the R of n, the R of n, the area from the right endpoint, you can write this notation. This one will be the limit of n approaching to infinity of f of x1, which was that height that we calculate, times delta x. I'll explain to you here what is delta x. Let me just draw two rectangles here to make it clear for you. This area, this difference, I will call it delta x. Agree? We usually show the difference by this sign, delta. If this is x1, if this is x2, then delta x equals x2 minus x1. From here to here, again, it's delta x. And if this point is x3, then delta x is equal to x3 minus x2. But all these areas, we selected equal. That's why at the beginning I told you, you can have different rectangles, but we try to divide the area under the curve to equal rectangles because I want to have this delta x equal in every single point, right? Now, same graph. Here I named it A, here I name it B. Here let's name it x1 or x2 or whatever you name it, correct? Look, actually this point is x0, right? But instead of your x of 0 is equal to this number, which is A, which is your starting point. This one is x of n, the last triangle, correct? But your x of n is equal to B. Always to calculate the delta x, you subtract this from this, correct? It means the formula for the delta x is b minus n, which gives you this distance. This is b minus n. b minus a, sorry, over the number of rectangles that you divide the area under the curve. That will be your formula to find the delta x, or to find this width. How much is this width? Correct? Take the total interval, divide by the number of rectangles. They will tell you divide in 4 equal pieces, divide in 8 equal pieces, 10 equal pieces. That gives you this small portion. This height in the formula, I name it f of x1. Actually, you see, this is your y1, right? In the previous example, you were squaring this number because the function was a square. Whatever the function is, this point or this side is the f of this point, right? That's why in this notation, I used Rn equals the limit of f of x1 times delta x plus f of x2 times delta x plus dot 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 f of xn delta x. And your delta x is always b minus a over what? N. Same notation goes for the left side. It's basically the same. Correct? Now I'll show you how I am using delta x in the next example, this method, correct? Let's take another one. For example, they give you this function. Let's take y equal, which one is good? Cosine x? F of x equal cosine x. They are asking you to find the area under the graph of cosine from 0 in a closed interval 0 to pi over 2. I want to calculate this area for you using 4 rectangles. How? First, I have to know the graph of cosine. Everyone knows the graph of cosine? Hopefully. What's the shape of cosine?
It starts at 1.
Starts at 1 and comes to where? Pi over 2, agree? Then it goes down, comes back up. I don't care about the other part of the graph because my interval is from 0 to pi over 2. I will calculate this area, basically. The area between the graph of cosine and the x-axis, under the graph of cosine. How to calculate? Using 4 rectangles. This number is actually your A, this number is actually your B, and closed interval AB, right? The first thing to do is, I want to find, okay, I will divide this area to 4 equal pieces, but how much is from here to here? I want to find that area, right? It's not that easy to just think right now because I don't know, it's pi over 2. Maybe you can, if not, why not using the formula? This is small area, or this is small length. Any of them that you want to calculate, let's draw these. This is small, distance is delta x. I want to find how much is this delta x, correct? Then delta x equals b minus a over n, which is, how much is b? B is pi over 2. Minus a, your a is 0. Divide by n. How many rectangles I have? 4. It means n is 4, divide by 4. Let's simplify. This one will be pi over 2 over 4, which gives you what? Pi over 8. Correct? It means this distance from here to here, here I have pi over what? Pi over 8. This is small piece is pi over 8. If this is pi over 8, definitely I know here I have pi over 4. If this is pi over 4, definitely it's easy to calculate to here. Here this will be 3 pi over what? 3 pi over 8. Now, let's use the left endpoint or the lower sum and upper sum method to calculate or to estimate the area under this curve. First, the upper sum. It means connect the right endpoint to the left. The right sum or 4 equals. How much is your delta x? How much is this small piece? Pi over 8, right? Times the right side, the height of the right side. It means pi over 8 squared, right? Pi over 8 times pi, f of pi over 8. How much is this length? If here is pi over 8, how much is this length? What is the function? How much is this length? Cosine of what? Pi over 8, right? Plus, again, the second delta x is pi over 8. Times this height. What is this height? Cosine of pi over 4. Plus next one. Again, pi over 8 times this height, which is cosine of 3 pi over 8. Plus again, pi over 8 times cosine of pi over 2, which is the last one here. Pi over 8 is in all of them. Make easy your calculation. Or 4 equals pi over 8 times cosine of pi over 8 plus cosine of pi over 4 plus cosine of 3 pi over 8 plus cosine of pi over 2. Now, our 4 equals pi over 8. Help me, please. Cosine of pi over 8. I don't have a calculator. Give me cosine of pi over 8. Use your calculator. Decimal or fraction is much better if you can find in fraction notation. Or decimal still it's okay because you're looking for the area. Give me 2 until 3 decimal place. Cosine of pi over 8, please. Anyone with calculator?
I got 0.999.
How much?
0.999.
999.
999 plus cosine of pi over 4.
Same 0.999.
All 3 digits 9, 3 decimal place,
Yeah.
999.
Yeah.
Plus cosine of 3 pi over 8.
Same thing. I got 0.999.
Yeah.
Wow. Plus cosine of pi over 2. Definitely, I know this one. Add these numbers, please. $2.997, right?
Does our calculator have to be in radians when we calculate this?
Yeah, your calculator can be, and it should be in radian, yeah.
I got a different answer when I had it in radians.
Yeah, that's. I just realized that mine was in degrees.
The numbers that you gave me, they are in degrees.
Yeah, my bad.
Ah. That's why I should put a calculator close to me. Calculator. Give me back the numbers. We are dealing with pi. Please give me in radian, right? Cosine of pi over 8.
It's 0.923.
7.9.
No, 0.9. 238.
23. Next one, cosine of pi over 4.
707.
0.07 what? At least 2 more digits.
707. 0.707.
707. And 3 pi over 8, please.
0.383.
0.383. Now add this 3 number, please. Ideas, answer, approximation, exact. Albert Einstein is really right now upset. You are adding 3 decimal numbers. It shouldn't take 30 minutes, right?
Yeah.
What is the answer for these 3 numbers, please?
I got 2.013.
013 times pi over 8.
I got 0.7905.
0.7905.
Yeah.
What do you think if I showed the area under the graph of cosine with A? Is this number is greater than that area or less than that area? Look at the graph. Is this less than that area or greater than that area?
It's
Less
less
than,
than-
right?
Yeah.
It means your area should be greater than this number, 0.79. Now, do the same thing. Find from the left side. I'll just graph it for you and I'll stop here. You will do the rest at home. Because nowadays I'm doing a lot. You guys are kind of relaxed. It takes you 30 minutes to add 3 decimal number, correct? I want to see that you are building your skills really good, becoming faster. I'll just show for you the graph and how I'll divide. Here I have again pi over 8. Here was pi over 4. And here was 3 pi over 8. Now connect the left hand. It means you're now calculating this area. Using the same method, again, your delta x is the same. It's not changing. Delta x is still pi over 8. But these, because you are using the left endpoint, you have to look for the cosine of 0, cosine of pi over 8, cosine of pi over 4, and cosine of 3 pi over 8. Do you want me to write that step also for you? To find the left L4, it will be pi over 8 times cosine of this, cosine of 0, plus pi over 8 times cosine of this left side, which is pi over 8, cosine of pi. Plus pi over 8 times cosine of pi over 4 plus pi over 8 times cosine of 3 pi over 8. Do the calculation, give me the last answer. It's okay that we are not in face-to-face. Still, you can work with me, right?
I got 0.790.
0.79 what?
0.
What was the other one? 0.790, same thing? And the same? Should be greater. Did you multiply that with pi over 8 also?
Yes, I did.
I got 1.18.
1.18, right? This number looks kind of okay with me. 1.18.
18.
Look, now your A should be less than 1.18 and greater than 0.790. If you look between these two numbers, approximately the area will be 1.06 or something like this, or 0.06 actually. That's the area under the curve. Because why I end up with this number immediately? Because the book, I have the book right in front of me. The book actually used a lot of those rectangles, correct? Many of them, more. Even they use the midpoint method. That's an accurate kind of number, approximately, still I will say approximately, the area under the graph of cosine from 0 to pi over 2 will be 1 point something, correct? This is what we call the rectangle method. I'll ask you now to do something at home. Next day, definitely, I will not focus on this. I'll give you slowly the other methods. The graph that we did today, y equal x squared. When you go home, or you are at home, when I stop this meeting, when you have time, divide this again to 4 equal rectangles. Use the midpoint method. What does it mean? I'll just explain it for you. What does it mean? For example, this is my rectangle, the first one. This is my, let's say I divide it to 3 equal pieces because I don't want to change my shape. What is midpoint? What I will do, I'll try to find the midpoint of this distance. If I divide to 4 equal pieces, this one will be 1/4. What is the half of 1/4? Half of 1/4 is 1/8, right? Also divide 1/4 and here you have 1/2. Find this, connect the midpoints with each other, all the midpoints, and try to find the area under the same. And after that, compare what you did using the midpoint. Is this your area is kind of similar to the area that we calculated in example 1? Do it, correct? But soon it's just one problem in the test will be this way. The others using the integral formulas. Next day I'll start slowly to explain for you what is definite integral. But at least today I gave you an idea. What does it mean? Why integral? What is integral? What was the purpose of integral? You are looking for the area under a curve, any curve, correct? Try to do this at home. If not, next day I'll do it for you. Then I'll start the lecture. Now, I announced at the beginning of the class also, those of you that you didn't take test 3, it's okay, but please submit homework number 3 for grade, correct? You don't want to miss your homework. Submit it to me and I'll grade your homework number 3. The problem with the Canvas is the Canvas cannot drop your lowest score. It doesn't have that system, but I have it in my computer. If you want to see your overall grade, remove your lower score from the between 3 tests, add the numbers, and you can see where you are. Or maybe I'll send you a report. I can send you a report, but to be honest, I have like 50 or 40 students in the class. I have to send 50 individual emails because I cannot use Canvas, and it will be a lot of kind of work for me. The easy way is to drop your lowest score, add the other numbers, and it gives you the total and see where you are. You are A, B, hopefully everyone A, B, not C. It gives you your overall grade, correct? Because Canvas cannot drop the lowest score. That's why I cannot show you on the system. Do that, correct? And if you have a question, if you couldn't do that, ask me. I'll give you your overall grade. Any other question for me?
So Professor, for the tests, like if we already got like, let's say 100% on the other 2 tests, we don't have to take the third one?
Yeah, you don't have to take the third one, but please submit your homework 3, right?
Gotcha, okay.
Only homework 3. Even if you have 2 80s, if you are okay, I have in test 1 80 test. 280. If you are happy with that, no problem, don't take test 3. But test 3 is definitely coming back to you on the final. Any other question?
So we're gonna have a cumulative final, right?
Yeah, I'll try to minimize it for you. Not the full book, not the full 5 chapters. Maybe like 3 chapters, the last 3 chapters.
Okay.
But you are not worried about chapters, right? I'll give you a study guide and you are just following my study guide. It's not anymore about chapters because I give you a study guide, right? Any other question? No? Then I'll stop the meeting. See you all Wednesday.
Okay, thank you.
Thank
Thank
you.
you.
Thank you.
Thank you, Professor.